Hello, everyone. Welcome to Technical Toolbox's webinar, Digital Modeling for AC Interference with Joe Pikas today. My name is Kesley Price, and I work here at Technical Toolboxes. We'll get started here very quickly, but first a couple of logistical details I need to cover. If you have any questions on what we're covering, there is a chat box or questions tab in the top right of the screen of your webinar interface. Please feel free to send us any questions you may have throughout the webinar, and we will do our best to cover all the questions we receive at the end. We will send a copy of the webinar recording to all registrants and attendees via email within the next 2 days, and you will also be able to see this recording available on our YouTube channel. So first, I'm going to get started by showing our agenda and kind of talking through that. We're going through the introductions right now. Then Joe's going to move on and talking about the problem that we see today in the industry with AC interference, the consequences of not modeling that problem, the invisible threat of episodic events, AC modeling solution, moving on to the development and enhancements that we've added to the AC Mitigation PowerTool. And then Joe's actually going to give you a live demo of the tool itself, and we will end with a live Q&A where we will address all of the questions you've submitted through the chat. Before we get started, we wanted to poll the audience at the beginning of the webinar to see where you stand with your AC interference. So the poll we will show you is kind of to help us gauge how you're currently tracking and modeling AC interference. So how are you currently identifying and mitigating AC interference on your pipeline systems? We'll give that a good 60 seconds for everyone to answer, and this will kind of help us gauge how we follow up after the webinar and how we get you the right resources and potentially answer any questions you may have. This also helps us focus in on areas on where we want to enhance our tool in the future and building out that project timeline within Technical Toolboxes. So please answer that, and then we will move on here shortly. Another 5 seconds, and then Joe, I'm going to turn it over to you, sir. Just give it another second. Perfect. Take it away, Joe.
Okay, well, good morning, everyone. And what we're going to do is you could see this wonderful picture here. And this is typical, especially in an urban environment. And I've been working with this kind of stuff literally from the late 60s. It's hard to believe, even when people didn't even believe in it. And I'll tell you a little story about that in a few minutes. Okay, so this is pretty obvious. This is what we're dealing with, AC induced corrosion sources. And this is our challenge. And we have clients overseas that have entered over 130 power lines. Could you believe that? That's how bad it's getting in some places. We also have AC power lines that don't have to be in the pipeline right away to interfere. And what are we talking about? Reconducting. In other words, they're increasing the power of these systems 3 to 4 times by replacing the conductors. So this is what we're dealing with. We're also looking at, and this is a challenge. These could be quite a distance away, half a mile, and some of the loads are tremendous, up to 10,000 amps. So keep that in mind, per phase. Often unnoticed until we don't really notice this stuff until we run a corrosion ILI run, and then we begin to see these little areas of corrosion that just happen to be facing the tower, the power line. Isn't that nice? And then we and we should be thinking about modeling to avoid the costly and time-consuming calculations. And this is what it's all about. You could do a preliminary study very quickly and see, where am I right now? What are we doing? What's going on? And you're saying, well, I don't have all the information. Well, we give you some default information, and we even give you some factors, to get the peak current. We with our software, you could use a factor of 3 for the default to get a peak current to get started. So you don't have to wait until a power company comes gives you the information. You don't have to count the number of discs on the insulators and all that other stuff. And it's even more costly if you don't do anything. And I just saw something the other day. I couldn't believe it. AC power systems will double by 2030 just due to AI. Next, Kesley. Okay. Remember I said I've been involved since literally the late 60s, 69 to be exact. That's when I got into corrosion. The AC corrosion has been a problem with the oil and gas industry more than 60 years. And why did I say 1969? Well, there was a study done by the American Gas Association and the company I work for, Transco, now Williams Transco, from 1964 to 1968. And I just happened to come in at the time when that study was finished. In fact, they were still analyzing the coupons, and and at the time, no one believed that there was a thing called AC corrosion. And that's when we discovered, by accident, this is an accident. You're not going to believe this, that our coupons that we put in there, we just happened to coat the edges of the coupons with an epoxy, a liquid epoxy. And guess where the corrosion was? It wasn't on the coupon because of the size of it. It was on the edges of the coupon where we put the epoxy. Voila, current density. And we didn't realize it. We understood the concept, but we didn't know what values at the time. But that 4-year study opened our eyes. Unfortunately, I have a copy of it. It was hand typed back then. Uh, it showed one of the things it demonstrated was this effect. But the problem, it only went out to a handful of people because not many people were interested in AC corrosion at the time. In high consequence areas, multiple underground facilities run underneath the country's urban and suburban areas, and we know that. But but we should know where they are, because pipelines will couple with other pipelines. Okay, there's a mutual effect, so we should put them in our model too. Multiple utilities such as water lines, natural gas lines, and so on coexist. We've already been through this many times, including everything else in the world out there. And we need to be cognizant of those things too. Pipeline operators today do not have many choices to install new pipelines in separate right-of-ways. And even if they did, it would soon be filled with other utilities, particularly AC power. And then the thing we need to think about is the mix of these and how they affect each other. We can't do anything about it now. From a land perspective, it makes good engineering and economic sense. However, from a corrosion perspective, uh, it's not a cool thing. It's especially with the newer reconducting power lines. And then some of the power companies are saying, the heck with reconducting, we're going to just double our voltage, from 345 up to 740 kV. So we need to think about how these companies are uh, upgrading their systems, and they offer some new challenges, which we'll talk about today, due to these AC effects. And I'll show you a demo on something I ran with the reconducting system. The consequence of not modeling, of course, is electrical power lines carry the current where this magnetic field is set up. And this is a place. This is up in New Jersey, and you can see there's multiple pipelines in this right of way. There happens to be, I think, 5 different pipes. I know that the two that I worked on was the 30-inch and the 42-inch. There was a 16-inch was a foreign crossing. that ran parallel, and I think there was another 8-inch liquid line in there too. So this is typical of what we're dealing with. So we need to be cognizant of all of these lines. The linking of AC current to the induced parallel collocated oil or gas lines we need is a major factor. And of course, the pipe near a power line, particularly a tower, is pretty important to know what that distance is. You know, whether it's going to be a conductive fault or an inductive fault. The good thing is most faults are inductive. The ones that are conductive are very close in proximity. So, you know, to the pipe itself, particularly their grounds, you know, at the base of the tower. So from an inductive effects of the pipeline, AC corrosion can cause if we're dealing with steady state issues of the micro holidays. And what we're talking about is 1 centimeter squared or less, or in that range. And then also we need to think about the lightning strikes. Where am I located? Are you in a high lightning strike area? You know, what effects will it have? And so on and so forth. What kind of episodic upsets occur? Like in this area right here, we had 5 substations within 15 miles. And you know what the big problem was? The power company didn't know when they were going to turn them on, and which ones were going to be used. Why? Because they had industrial loads at night that they couldn't run in a day up in this area. They ran the commercial and the residential in a day and industrial loads at night. And even then, they had difficulty controlling things. So that even makes a bigger challenge, you know. And this is where you got to run recorders to see what's going on. It's amazing when you run recorders how what things you see in the middle of the night going on. So in addition, the apathetic upsets, lightning strikes, and things of this nature. You know, the last thing is we need is a short circuit condition as a fault that's going to cause a lot of problems, and then also the impact to the pipe itself and the coating. Next slide. And so this is what we're talking about, this kind of stuff. And you know, and it's pretty significant, you know, particularly such as lightning strikes. Uh, Back in the 50s, before my time, was it much before? The company was using lightning arresters and spark gaps to handle this kind of stuff, lightning. They didn't know anything about AC corrosion until that study was done in 1969. So even back then, they were concerned from the mid 50s on, when there was several punctures due to lightning. Uh, the industry began to wake up in the mid 50s at that time. High winds could cause equipment to fail. You know, contacts. You know, with the conductor swinging and so on and so forth. And then issues to the large amount of energy that could be transferred from the tower to the pipeline, and 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 it's going to go right to ground. The largest percentage is going to go to ground. This is why we need to know where the proximity of these towers are, particularly the grounding rods. You know, it's not the center of the tower we're worried about. It's the legs of the tower with the grounding rods. And these fault conditions only last short periods, you know, milli or microseconds, but still can be a safety hazard both to personnel, you know, working around the pipeline. Next slide, please. Okay, so what we have here, and we're going to get into this in a little bit, is a graph of what we just modeled. And it didn't take long to model this. I added some mitigation in here. This red line happens to be a discrete anode near an isolating flange, and the rest of them are distributed anode systems. You know, to bring this down. Uh, this was one that I consider a high reconducting uh, change that occurred, and I just wanted to see what would happen. And we were able to model it fairly well and bring it down below 20 amps per meter squared. And we get questions all the time sometimes about, should I use 20? Should I use 30? Should I use 50? What should I use? And we'll talk about that later, of, what criterion do I need to, you should look at also your DC current density. Well, DC current density impacts what you should be looking at for your AC current density. If it's greater than 1 amp per meter squared for DC, then you better start using 20. And if you're up that high, that means you're in trouble to begin with trying to protect your pipeline. So that's another problem. So it's like the dog chasing his tail. And so we've been involved. Technical toolboxes have been involved in this since the late '90s with Dr. Dubkowski and PRCI work, and it was the last 20 years. They've been improving the product. So just to let you know, the biggest focus has been in the last 10 years. So in the development of all of this, it has enabled uh, the whole purpose of upgrading and uploading was to make it easy to use. That was our whole purpose. We've seen other tools out there, but our purpose was this: let's not spend all our time modeling. Let's spend our time what we need to be doing out there in the field and how we're going to address these issues. Like I said, in the beginning of this presentation, in 5 years, our AC uh, uh, needs are going to double. Next slide, please. And I believe that will be, oh yeah, there's one more. Uh, this is a typical uh, uh, way, we had to mark everything. We had to box everything out where it was going to be dug, and that white line was where the mitigation was going to go, and everything. So when you're working in tight spots like that, you don't have big equipment to work with. You have to be working with trenchers and stuff like that. But the point is you could design this stuff very quickly, and the AC um, can be run in hours, not days or weeks, to get the same engineering results. And using this information gathered in the field, engineers and techs can create their models literally in minutes, not hours. And that's one of the things we're working on now is taking more field data and relating it and comparing it and using it to help model also, what the model is saying and to tweak it. So this is our focus for this year. So I just want to let you know that we're going to put a lot of focus on data gathered in the field, whether it's coupons or spot ratings and things of that nature. So just FYI regarding uh, our future for this year. So I'd like to bring that out. And I believe the next slide will be coming up. Is that correct? And this is our typical ArcGIS system. We're using Esri, and it integrates and complements the AC program, the AC Power Tool. So this is why we call it a power tool. And you could create your sections rather quickly. It's point and click. You could do if you want to do a 25, 30-mile line, you could click and point and put the sections where you want them, not where some other program says to put them. Based on the geometry, based on the resistivities, based on the transpositions, based on road crossings, whatever's there, or other construction restraints if you're going to build an AC mitigation. And again, you know, uh, right now there's multiple types of criterion out there. We follow the NACE guidelines using the Barnes layers, the 3 layers. We feel that's the most effective one and universal for this type of work. We're not building substations. We're 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 building mitigation for lines that are running longitudinally, not in specific areas that need to have multiple layers other than the Barnes layer. We're not building substations or power stations, so keep that in mind. This is a pipeline, and we're using single and combined graphics with different views. We got cutoff voltages, which I'll show you in a minute. We're using also we use our spreadsheets to bring data in and out, import and export, and most of the projects are done uh, in hours, not days, and then our training is less than 2 hours. I've had an engineer come in and saying, I don't even want to be trained. He says, I think I could run it by myself. And he did. I couldn't believe it. So it's intuitive enough. It's intuitive enough that you could even do that yourself. But we would prefer to do at least an hour to 2 hours of training or more, whatever was needed. So next one, and I believe we're moving up to the live demo. So and and we're gonna select screen 2, share, and here we go. So what we have on this screen is uh, our Esri map, and this is what we're using, this ArcGIS map right here. And we take the information from the map here, the pipeline. All we do is highlight it, and once we highlight it, we just point and click and then bring it right over into this program, our AC program, both for the power lines and the pipelines. It's just a point click technology. And just to give you an example, I'll just bring up the power lines right here. We could bring it in through the map. If you look down on the right hand corner, select power line for map, or we could select it from my hierarchy. And if we have our hierarchy is over here, I just go into the hierarchy and select the line, and it pops it right in. How's that? So so once we get over that large feat, okay, we have our we have our pipeline. We have our pipeline in the right of way that we're going to study. We have our power line or power lines, whatever it is. So that's phase one. Phase two is adding the data to it. And like I say, if you don't know what the information is, there's a lot of information sources out there. There's a lot of websites you could get information from, but let's just say you couldn't find it. Uh, you could always go to Google Earth and 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 get a view of the towers themselves, and just count the disks. And we have little simple equation to figure out. Oh, that's a 345 kV line. Okay, that's a single vertical. And this is how we determine this stuff. Single vertical. It could be a horizontal, double vertical, and you just have to fill in the blanks of from that point on. Uh, Count the disks, and that'll give you an idea what's going on. We'll give you some default currents, and what we recommend is not the maximum current, but the peak current. you know, and keep in mind its duration too, because today we're dealing with longer heat waves or and cold waves and so on and so forth. So this is what it's all about, and we should be looking at the peak, when we're mitigating. And why? Because this is where we're going to have our most detrimental effects. This is a compressor station, and at this point, I decided, well, they got an isolating flange here. You could see the pig traps and so on and so forth here, but they have an isolating flange. The station is isolated on each side. We're only looking at the east side of this at this point in time. If you notice, decided what we're going to do is put a decoupler right across that isolating flange, right? Because that station is very well grounded, extremely well grounded. Uh, that's another way to dissipate the AC. We don't have to dig in this area here where there's a lot of valves and other piping. And then we started our mitigation here, and I used a distributed system. Okay, why? Because what do we have a change in? Anytime you have a change in direction of either the pipe or the or the power line or both, you begin to see peaks. And so we were able to mitigate something like that. Going along, we had some other changes in here that necessitated additional mitigation and so on and so forth. And this is what we're dealing with. So when I ran the program and so on and so forth, and we had a departure in here, and the same thing, we needed to put a distributed system in there. So it's and also you could when you create your sections, you could put them on each side of the road, because if you're not going to directionally drill underneath there to put mitigation, you could do a whole host of things, and you could add them in, take them out. The sections, it's just, but we always recommend is try to get the towers, for the purpose of for faults. At least try to get those. So where they're located and so on, because the same information that goes into this program here by creating a section, and this is simple. Let me just show you something. I could just turn that little pencil on, drawing pencil, and if I wanted to put another section in here, I just go a click and point, and there it is. And then all I do is recalculate, and it'll recalculate all the sequence of lines, and that's it.
Hey,
I
Joe. We did have a
Yes.
question come in that relates to what you're showing right now. They're asking, do the same concerns exist with underground HVAC?
Okay. When you're dealing with underground systems, remember they're bundled together. Okay. And uh, and what we're doing with a power line. Let me just go back to the power line. Uh, I'll open that up. What we're dealing with is the phases aren't bundled. Okay. Whether we're dealing with whatever system we're dealing with, whether it's a single, vertical, double, and so when they're bundled, what happens is they counter each other, and the net effect is pretty low. Now, what you got to be concerned about with a bundle with something like that, underground systems, is the grounds themselves. Okay, they have a tendency to open up, uh, corrosion. They have a tendency to open up from damage, lightning and things of this nature, and they also have a tendency to discharge. And if you happen to be where they cross, you could have some significant effects. But generally, for induced AC issues, they counteract each other. And what we're dealing with is the phase. the phase right here, that this is what we're dealing right here. So we have to keep that in mind that generally it's the closest phases to ground that we're concerned with, but they all have an impact, and they're separated, and that's what makes it a lot different than what when you have something underground. Great question. Okay, so we also uh, supply most of the information, and if you were going to change the depths on these or the heights, you could do that. You could add these in here, the height of the towers, the shield wires, and so on and so forth. You have that option to put that in there. And then what I did is since this has some reconducting instead of the typical peak current in there for the typically in this case it was instead of 1500 amps this happened to be 4500 amps. So what we're saying is, wow, that you know uh, I got more challenges here. Well, you do, but you have more tools to address those challenges very easily and to mitigate this. And this is what we're talking about. So we have the tools here. Uh, like I say, I just played around with this. Within an hour or so, I had this mitigated and ready to rock and roll. Uh, uh, your biggest challenge is getting that data from the field. That's your biggest challenge. That's the one you got to look at, and so on and so forth. So keep that in mind. That what we're dealing with. It's more field related, and also if you have coupons out there, if you're doing any kind of AC studies, when you do a study, make sure uh, to use data loggers to see what's really going on, not just during the day, but what's going on at night. And that was the biggest surprise that I ever saw was was that issue I showed you in New Jersey was the worst situation was at night, not during the day, from the industrial loads. And that was a shocker. And the company that did that before didn't consider that, never considered running data loggers, and they just assumed, oh, it's not a big deal. It was a big deal at night. I couldn't believe how the loads increased so significantly, and that's the only way you're going to find out. So that's your challenge is get that field data, and so you can make those comparisons. You get integrated into your modeling because it has to be done. You need to know as much information as you can in order to have good results. So even if you didn't count the discs on the tower and you didn't get the information from the tower company, you could do a lot more by just running data loggers sometimes. Okay, so once we get the data, we got the options to mitigate, and one of the things here is we have three ways to mitigate, and I just want to point them out, and I'll watch my time so we have time for questions. Is like I said in section one, I put a discrete ground system. It could have been a little bit lower, but this is a little bit higher resistivity up in a mountainous area. So I kept it about a half an ohm, and so on and so forth. And I think the next area was let's see, that's line three. Section three. So I'll go down to section three, and then I put some distributed systems in, and they were contiguous here, and so on and so forth. And then you can see section 10, and I'll go down to here, and the same thing, section 10, uh, yeah, here we go, 11, yeah, 11, 12, yeah, here we go, yeah, where we have, oh, I guess it's just section 10, yeah, oh, 11 to 12, excuse me, yeah, so it's just there. Interesting, that's all I needed in that one. And that's the nice thing about it. You could somebody say, yeah, boy, that's a long distance. Well, then draw another section line in there and see if you could do it with half the anodes. That's another one. So you have those options to save money, and be cost effective to still being safe. So this is why I bring this out. And the distributed anodes do a good job as well as the parallel placement. And whether it's a zinc or copper cable, I'm a big fan of copper cable. I feel it does a lot more, particularly on the faults. When you're concerned about those issues, particularly with proximity to those towers. So once I do all that, I could also I could also make do the unmitigated. Uh, I could run the unmitigated, the mitigated. I can make the comparisons. Let me just run this one. I'll calculate, and here I have the same information. I can make the comparisons to what I have in the field where it's located. Just bring this over here and just expand it, whatever I need to do, to bring it around. So it matches up similar to what we have, and so on and so forth. And you could see what we've done here is we've brought the voltages are the green line, and the current densities are the dark green line over here. Yeah, I mean the blue line. Excuse me. Yeah, we got the green and the blue, and then the red, that's your induced currents. Once you install what, and you're saying, well, what's that red line for? Well, take a look at the current that we're draining. About 100 and let's see, what does it say? 168 amps. You're going to say, well, what do I need here? That's to help you size your cabling for your mitigation. If I have to drain 168 amps, you better put some heavier cables in there, to your anode systems, or decide I'm going to go with a copper cable versus zinc. Uh, so, like I say, I'm a big fan of copper because it lasts a long time. I've got I have a system in there over 20 years, and it just got just minor pitting on it, and it's draining heavy current day in and day out. So, and what I mean by heavy, 50, 60 amps. So this is what I'm talking about. So think about performance, not just temporary. Okay. So this is some of the things we need to think about when we're designing. It has to be, work. You have to just you should have a background in, at least in some background in corrosion. For design and things of this nature. So it really helps out. Uh, uh, so get your AMP and NACE certifications. Okay. So I put in my cutoff voltages. I put a 15-volt cutoff voltage. Why? For test stations and stuff like that, valves. Anybody wants to work around them. We don't have anything greater than 15 volts. And then I put a 20 amps per meter squared in this area, simply for the fact that uh, uh, I felt that that was the best criterion for this specific condition. You may have to change your tune a little bit if those resistivities were like really, really low. So keep that in mind too. And so once you get all this information and you have it under control, you could produce a report. And that's something I'll do right now. And I'm going to run a report just to show you how easy it is. I'm going to take out a little bit of this information. I don't have bond connections. So I don't have a second pipeline there. So what I'm going to do is generate the report. Uh, so I'll do it live, and we'll see what happens. Okay. The problem with doing it live with there it goes. Um, Tells me to wait. Okay, I'm gonna wait. Uh, Page unresponsive. There it goes. Uh, the problem doing it live with on GoToMeeting or whatever we're dealing with is that the bandwidth. We're when we're dealing with all this. I should have run it before. There it goes. It's being generated. So that's why I have to talk through this. Okay, here it is. Even with the bandwidth. Okay, so here's our mitigated. Let's see. Okay, oh no, this is our map, and let me run this one. And this is the mitigated. And here's your discrete, distributed, and parallel placement, and also in the data where it's located, which, which section it is, so on and so forth, which is nice. So just want to point all that out to you. And then we have the unmitigated one, which will be coming out soon. Okay, so I just made it short just to save time. Okay, so the other thing we want to talk about is the fault. All the work we did on AC mitigation. Guess what? We just could pull that information in. All we have to do is pull that same case in that we just worked on, apply the changes, and I'm going to say the uh, uh, the faults are going to be about 10,000 amps per side, or 20,000. Because it's a reconducting wire, so they're going to be a little bit higher. And I selected average tower resistance is about 10, tower separation about 900 feet, and the faulted tower node is about is in section 11. That's all you have to fill in. All the rest is from Power One, Power Line One, 345. It was self-populated. You take the lowest conductor, and then I took out this shield wire. But what's happening is it's going to be a split. When if the tower is hit, it's going to go to the left and the right, but most of the current, induced current or conductive current, is going to go down to the tower legs to the ground rods. So keep that in mind. So that's something we need to consider. So remember, when you're measuring from the program measures from the center of the tower. So we need to think about not from the center of the tower, but we need to think about the closest leg to the pipeline, and so keep that in mind. Okay, so same thing. We just fill these in, and guess what? I selected this one because this is the closest one, this distance. Okay, so I selected that one. I have some mitigation in this area. So let's run a calculation and see what it is. I'll reset this, my map, and we'll go from here. Let's calculate, and let's see what we have. And it's going to be surprising that there we go. And it says please wait. Okay, and it waited, and it's going. So here we have the same thing. So here we have the same thing, and where the mitigation is, and then also we have where the where it is we're at number 10. Let's see, 11, I guess it was. Yeah, here we go down right in this area here. Yeah, right here, 11. So I'll just kind of line it up there. And it's saying that guess what our maximum voltage is and our current. Our maximum voltage is just here's your 300 volts right here, and we are about 326 volts. And then the current is this is a fault current is around 2786. Let's just say about 2800 amps. Uh, so so we could look at this rather quickly, and if you notice the amps are up, the voltage is down. Okay, so keep that in mind. When you have and that's based on the way the circuits are run. And we could do the same thing. We could create another report, and it's the same thing. I could just come in. I could run a report here. I could run a report up here. It doesn't make any difference. It'll be the same thing. And I'll just uncheck the ones I don't want. It's easier that way. Generate a report. And that's how it's done. And this is what makes this program so cool is that you did 95% of the work, and then for the fault is just fill in the rest of the blanks in there, whatever you're dealing with. And here's your information. It'll give you your surface potential, your step potential, and your touch potential. Oh, and then all of your information as we saw before, which is pretty cool. This report is a little bit longer. These reports could get up to 60 to 100 pages very easily. So you got to be careful. You don't get a lot of people don't want to see all that information. So but it's there, and you could also what's really cool is let me go back here. What is really cool is you could also run if you come up to reports. You could run it as a PDF. You have different options to run these reports. So I'll just close this. Okay, and you could save it to a repository and so on. We also have a collaborative on and off. So if others in your company are running similar software, you could see what they're doing and vice versa. But you can't change their data. Once it's saved in that case, that's your data.
Hey,
So,
Joe, before you switch off of the screen, will you pull up that report one more time and show the mitigation part in the report? Someone commented that wasn't very clear. Would you mind elaborating on that?
okay. Let me look it up here. Let's see.
Yeah, I think you have it in the tab still there. Yeah,
I may have went too fast.
that's okay. But the question, the point that was submitted is the mitigation part in the report is not very clear. Will you please elaborate?
The mitigation. Well, the mitigation is here, right? And then we also have it here. We have it both the mitigation in here, as we showed before, and what type it is, and what section it is, and then we have it here in the graph, and then we have it here on a map, and uh, the fault is going to be.
Perfect. Thank you, Joe. And
Yeah. So,
I know we do have a
sorry.
couple more slides we want to get to. Are we ready to move to those?
Yeah. So yeah, we're finished here. and then we'll go to your other slides, and then we'll have Q&A. Okay? So if you could switch
Perfect.
that over.
Yeah, so I don't know, Joe, if you wanted to talk to this slide, but we do, outside of our software, offer training. We actually offer training, obviously, in onboarding with the software, but we also have the training hub available as you've seen it in the past on the training hub website, but we also have that now integrated within the pipeline hub and accessible to everyone with a license. So we offer, Joe himself actually is one of our SMEs that offers online live webinar events, live in-person events, and then on-site training by arrangement. And if you're looking ahead at our website and within the Pipeline Hub at the training portal we have in there, some of our current and upcoming AC mitigation webinars related to kind of what Joe showed today. We have one coming up June 4th that covers cathodic protection system design for buried pipelines. And then another one related to AC mitigation, pipeline AC interference and mitigation, August 27th. So if you have interest there, please let us know or visit our training hub website and you can register online for that. If you
And
are,
one thing,
go ahead,
yeah,
Joe.
one thing I want to point out is when you do your first project, we are going to be with you hand in hand. We're going to hold your hand the whole way. So it's not going to be an example project. It'll be your first project. I'm serious, and you'll have that done. Okay, and that's one of the things we'll work with you on. And of course, the first time you do it, it'll be obviously slow until you get used to the software. But like I say, if you have the data, if you have all the data, gathered and you're ready to go, it'll be a cakewalk. So I just want to point that out. Okay. Thanks, Kesley.
Yeah, and so Joe, thank you so much for the live demo and all of your talking points that you covered for AC interference. We do have some good questions from the attendees, and I know we only have a few minutes left, so we want to get to those as soon as possible. So real quickly here is our last poll question of the webinar. Which area of AC mitigation would you like more support with? This helps us funnel any potential questions you may have, where we can follow up with some either content or a live demo for you and your team, a one-on-one or with your entire team, whatever works best for you. Do you see that you need more support with AC interference modeling, fault current impact analysis, GIS data integration and reporting, selecting and designing those mitigation methods, or maybe building just a TVC compliant report is a big area of focus for you that you need support in? We're happy to follow up after the webinar regarding any of these topics. I mentioned it in the chat, but in the top right of the webinar interface, if you haven't already, there is a tab labeled materials, or it looks like a little notebook with a paper clip on it. We do have our AC PowerTool Enterprise Plus one pager there. I know that's a mouthful, but what that is our AC mitigation power tool that you saw Joe demo today, plus the veteran industry consultant like Joe Pikas, who will be assigned to your project and help you expedite the before, the during, and the after of the studies that you're looking at. They will walk you through, be side by side with you through studying the right parameters and making sure you're getting the full potential from the AC Power Tool. So this has been a highly requested package in the past from current users. So we launched this last year to better serve our AC Power Tool users who need a little extra help there. So please feel free to check that out. Moving on, we have our thank you slide. So now we're going to cover our live Q&A here. So let me go back here, Joe, to our questions, and I will funnel these to you. First one being, do you have recommendations on what equipment to use and length of time needed to record the power line data? And in parentheses, we've got the data loggers.
That's a great question. One of the things we found is I would recommend at a minimum of a week. And why? Because we were surprised too. We put them out. We were thinking maybe 1 or 2 days. But when we checked them, we saw there was a difference between day one and day two at night. And I said, well, wait a minute. That means these guys, um, the power companies, aren't sure what they're doing, and we called them. I just happen to know them well, because I worked up in that area, and they said, Joe, we don't even know ourselves because these companies kind of tell us what to do. So sometimes when you're in industrial loads and things of this nature, even commercial, I mean, commercial you could always predict, but industrial loads are a challenge. I could say that. So if you're dealing with those kind of loads, keep that in mind. Because they can be a challenge. They may not be quite consistent, Monday through Friday, work day. So keep that in mind. Okay, at least a week.
Perfect. Thanks, Joe. We just have one request, so maybe just clarify here. Would you please provide the name of the GIS software and the AC modeling software that you showed? So maybe just give a little clarification there, Joe.
Okay. Yeah, I mentioned Google Earth. You could. I mean, everybody should have Google Earth on their computer, just because it's fun to use. Uh, but what we use the ESRI software, and this is what most pipeline operators use. Why? Because it's a consistent software that you could use, but it has some other advantages. So for checking out things and stuff like that. So you shouldn't be just stuck with one. The Google Earth is free, obviously, and we give you the ESRI software when you get the program
Thank
that
you,
comes
Joe.
with it.
Here we have another question. What is the right way to work on pipe without any mitigation? Do we have any indications from software where to put the groundings or anodes, or do we have to arrange that from our experience?
It's where if I could let me go backwards. Let me go
Can we
to
change to a different slide?
yeah. In other words, what you'll see is you'll see these voltage spikes and AC current spikes that are quite high. Yeah, yeah. Another, yeah. I wanted to. Uh, in other words, you see all these peaks. This is what we're trying to do, and what we've done is lowered the peaks. Remember, I'm trying to keep these peaks down below 20 amps per meter squared and below 15 volts for safety. And you notice I flattened this out. If I bring up, let me bring up, can I demo again 1 second? And I want to show them the unmitigated portion.
Yeah.
So yeah, so I'm going to show you guys the unmitigated portion, and let me share my screen. Share screen, and here it is. And I didn't know how much time I was going to have, but let me just share you the screen. So we have a little thing here. It's disable mitigation. So what I'm going to do is hit this. Going to calculate, and look at the difference. 200 volts. Okay. And if I put my cutoff voltage of 15 volts in here and my 20 amps per meter squared, right? I'm going to put those two lines in there. This is going to just make you crazy and calculate. Okay, this is the nice thing about this software. You can make the comparisons. Hey, I got to do everything. Okay, so what I generally do when I'm mitigating, I start from the outside, each outside, and work my way in. So I start here, and obviously I don't have to do much here because we're away from the tower lines. If you look at the map, we're away from the tower line. Tower line's going away, so it really isn't, but it actually goes over this way. But I ended it here just for training purposes. But you notice, if I don't put the power line in, it goes down. So I kind of work my way, from the each outside, and then try to bring it down, and then work towards the middle, and that's how I start bringing it down. So if I started mitigating, how much time do I have? Uh,
Go ahead and
like
finish, Joe. You're good.
yeah, I'll just do the first one. Uh, um, I'll well, I have it unmitigated, but that's what I did. I did the first one, and then I did the down on the end, and then I come in and I did section 11, I believe. Yeah, there it is there, and you could use the parallel or the distributed, and that's what we'll work with you on, is which one should I use. Uh, you know, you got to look at the costs and things of this nature. You got to look at your terrain. What am I dealing with? What should I put in here? This is the nice thing about it. You can make your decisions before you get out in the field. So oh yeah, I could put that in there. I got a road, I got access to get in here, and all that other stuff. And we'll teach you all that good stuff. Okay. So so this is why you want to have the map, so you can make these critical decisions. Oh yeah, I could easily get in here and put this in here, and I don't have to worry about the piping in here or anything like that. So this is how it is. This is how it works. Okay. And I'd like to thank everybody for their your attention and your time.
Yes,
And
thank you, Joe, so much, and thank you to everyone who submitted questions. We had a lot of questions we weren't able to address live. We will follow up via email. We will get those answered by Joe and forward those over via email to you. Um, we will have a recording available on our YouTube channel in the next couple of days, as well as we will send this via email, the recording, to everyone that attended and those that registered that weren't able to attend. Special thanks to you, Joe, obviously, for the presentation. And again, to everyone in attendance and for all your questions. If you have anything else that you'd like to send over, here is Joe's email address and our website. Please reach out if you have interest in anything you saw today, or if you have additional questions you weren't able to able to ask, and we'll get back to you. We'd love to set up one-on-one demos with you or with your team. Please reach out, and we will follow up with everyone via email on the questions we couldn't answer, as well as with the recording. Thank you again, Joe, and thank you, everyone, and have a great day.
yes, thank you, everyone. And thank you, Judith and Kesley, who,
Appreciate it,
who
Joe.
assisted me.